It's good to see everyone here. So just I guess we're all here and we're all set up. So maybe we should just start with you panelists. I guess I'm not a panelist, though I feel like I might have opinions and want to interject. But maybe you could just briefly introduce yourself, quick introduction, and then I'll just start with a couple of seed questions. Starting, I guess, with Holly. Go from Holly, Dave, Glenn.
Sure. So I'm Holly Cummins. I'm an IBMer, and I currently sit in corporate strategy, sort of thinking strategic thoughts. But I've spent many years in the IBM garage as a consultant. So a lot of the sort of I think probably Dave knows this as well. The sort of the pattern as a consultant is that you have an opinion and then you go out and you meet people and you go, oh, why are you doing that? And, oh, that's interesting. It never occurred to me someone would do it that way. And sometimes you revise your opinion and sometimes you just sort of get depressed. But it's very educational. So then I try and share what I learn.
Hi, my name's Dave Farley. I'm an independent software consultant, as Holly alluded to. I'm probably best known for writing continuous delivery book, but actually I think I've got a claim for inventing microservices in the 1990s. I worked on an innovative project where we built loosely coupled, independently deployable things that we called at the time cooperative business objects using semantic messaging, and we invented our own version of XML. It was a very exciting, fascinating project. So I'm quite opinionated about microservices as a strategy for building bigger, complex systems.
Cool.
Hi, I'm Glenn Eggstrand. I'm a software architect. I've been a software architect for over a decade now, I suppose. I think that currently I'm at Optum Digital, which you may know as Rally Health, which is in the healthcare space. Before that, I was in Adobe. And then before that, I was at a dating site called Zoosk. And I think that it was during that time that I first saw one of Chris's meetups and or workshops. So Chris has been around my neck of the woods presenting and educating for a long time.
Oh, thanks. Well, I feel like I've learned from everyone, either today or in the past. And it's kind of cool. Continuous delivery is one of my favorite books. So great, everyone's on the panel. So at the end of Holly's presentation or Q&A session, we touched on this is in the context of microservice architecture and defining services and their boundaries. And it's like, what do you do with these objects that are pervasive throughout the overall domain? Like in, say, banking, in my simplistic view of banking, it's customers and accounts, and e-commerce, it's orders and customers. So how do you do decomposition beyond 2 or 3 services when you've got these core business objects? And then if Holly, you wanted to start just by finishing your thoughts there.
Sure. And I mean, it's one of those things that I ask myself all the time, because I've seen a lot of instances of it going wrong and causing problems. And I've seen fewer instances where I'd say, yeah, that's exactly the pattern. That's the way to do it. So I'm really keen to hear what the others have to say as well. But I think the sort of the strategies that you can come up with, one is sometimes we think objects are the same and they're actually different because they're used in really different ways. So although everybody has an order, in one context, it's what we care about is the customer address, and in another context, we care about the stock levels. And so sometimes we want to just actually realize that these things aren't the same. Other times, I think we actually have to accept that they are the same, and then we just have to write a contract for them in blood and, encase the API in cast iron in order to, and we just recognize that this is so common that it's not going to be very flexible.
Yeah, well, I think you sort of touched on concepts from domain-driven design, right? Bounded contexts and the same word having different meanings in different contexts, right? Like, say book, right? The shipping department has a very different view of what a book is from the marketing department. instance.
Yeah. I think the domain-driven design idea is important when thinking about microservices, because I mean, the whole point of a microservices architecture, it seems to me, is to try and decouple the pieces. You ultimately the advantage of microservices is that it decouples development. It reduces developmental coupling so that teams can make progress more independently of one another. Otherwise, it's just a service-oriented architecture. It's not microservices. So that decoupling is important, and I think that one of the things that I like in the definition of microservices is that in most definitions is that people say they should be aligned with a bounded context, and that makes sense to me. And if you'll forgive me name dropping, I was chatting with Eric Evans about this a couple of weeks ago, and he came up with an idea that resonated with me, which is that the kind of messaging layer is a separate bounded context. So actually, I think multiple separate bounded contexts. So you have the bounds of the service, and then the messaging is something else. The protocol of exchange of information between the services is another abstraction. And one of the things that resonates with me is another thing from Eric's book is that you always translate when you're crossing bounded context. So we should be translating the messages as they go across, and then that makes the example that Holly came up with an easier problem to deal with, where we have these ideas that are sometimes the same and sometimes different and sometimes related. So I think in a good microservices architecture, you've got kind of three layers of abstraction going on. You've kind of got the services themselves, you've got the contexts of the protocol of exchange of information, and then kind of floating above that, there's this top level thing, which is kind of the correlation of ideas. So the book ID that ties with this version of bookness and this other version of bookness, and those kinds of things.
Yeah, I saw that in your one of the very recent YouTube videos you put out on your Most Excellent channel. And I thought that was fascinating because it sort of aligned with an idea I had a while ago, where sort of within a service you obviously have a domain model, right, or bounded context. I can never really tell them apart, to be honest. And then there's an API, which supposedly should imply encapsulation, right? And the API is a model as well, which is not, because of encapsulation, it's not the same, right? It's hiding things. Somehow there's a mapping. And then at the application level, you could say tangibly with an API gateway, that's exposing a model to the outside world, and the API gateway is translating that model to respective service API models, and each service API is translating to internals. And I think that's
I think it's kind of turtles all the way down. It needs, if we're trying to use this as a model to manage the complexity of the systems, then we should be working to try and isolate those systems to some degree. Allow ourselves the freedom to have these little layers of insulation between one part of the system and another.
Yeah, and that actually reminds me in Selena's presentation. Unfortunately, she's not here. At Airbnb, they had a concept of like a cluster of services, and that had an API layer too. So multiple layers. Yeah.
I think that, Chris, you originally talked about this kind of in your scale cube. I don't know if you remember that. That was a ways back.
Was that before yesterday?
Yes, it was, sir. And there's different ways. It is very relevant to this discussion about the present and future of microservice architecture. How do you split up? Because it's always, eventually what was a microservice, people keep jamming more endpoints into it. Eventually it becomes a monolith. That's time to go through another split. And like Holly said, using bounded context is a good way. Like Dave said, kind of stratifying it, orchestration versus data, backends for front ends. I think I recently blogged about that. So there's all kinds of strategies. And, on the one hand, there's mitigating release anxiety. That's the problem when too much stuff is in one service. And on the other hand, Chris, you actually talked about this in an interview with Thomas recently about sort of the Conway's law costs. right? If I need to call another service and it's owned by a different team, but I need it changed, there's going to be some resistance to that because, oh God, now I have to open a ticket for that team, and oh, it's on their roadmap, and I don't know if they'll get to it, and maybe we can just think of something to do on our side, So there's both sides of that, right? And you have to kind of come up with, or ideally should come up with some way of partitioning what you need to do in a way that honors, both sides of that equation.
I think that the idea of kind of developmental decoupling is core to microservices. Otherwise, to me, that they don't really add any value. And it's one of the really common anti-patterns that I see, is that people don't observe that. And I would say the majority of microservice implementations that I see in the wild, where people claim to be implementing microservices, what they really mean is that they've got a bunch of services living in a separate repo. But they're not going to release those things independently of one another because that's too scary. So then they're going to test them all together afterwards. And that means you just got a big monolith in multiple repos. And that's kind of the worst of all worlds. That's kind of that kind of gives you no advantage that I can see.
I think
your IDE isn't going to help you,
right?
Yeah.
Yeah, there's no doubt about it. If you see 2 or more services, right, and you're using just like kind of traditional semantic versioning, not timestamp versioning, and they're on the same version, major, minor, number, you're like, okay, you've released it.
Yeah.
They're always released in sync. So look what we have here.
Yeah, I mean, that's definitely a smell, an indication that the boundaries are incorrect. So there's a few questions. Go on, Dave.
Sorry. Just one more thought on that is that I think the idea of just accepting that there's a higher cost to the decoupling. If you want to work with pieces that are decoupled from one another, there's a tax to pay for that. You're going to do some sort of translation. You're going to support multiple versions of the API in parallel, or whatever your strategy is to allow these things to change more independently. But there's a value in them being able to change more independently. So you invest in that value by paying the tax of the decoupling.
Yeah, and you hope that the value exceeds the cost, right?
Yes, it is. And sometimes it doesn't.
Yeah. I like that idea of the decoupling tax, though, because we often talk about the overhead of microservices themselves, but we don't always talk about the overhead just of being decoupled. And I remember when I way back when I first learned EJB, because of course there's a lot to hate about EJB, but one of the things that it was solving was that decoupling as well. And I just looked at it and my head wanted to explode, because I was just like, I don't understand what problem we're solving, and this is so complicated, and why do I have to change, is everything sort of traced through, and you lost a lot, but you in principle gained a lot as well. And I think there's sort of a similar thing, that having things spread across in that way has a cost.
Yeah. Well, I mean, it's like, if you got 2 modules and invoking the other with a method call, that's really simple, right? As soon as you package them up and have some form of inter-service communication, it's costly and more complicated, right? But on the other hand, by splitting, I said, like in that case of Airbnb, I think when they started refactoring the Ruby monolith, maybe they had 500 developers all committing to the same single monolithic code base, right? And I think they had a bunch of issues with that.
Mind you, just to put that into context, Google have 25,000 developers all committing into the same monolithic code base.
I know, but they have PhDs working on their build system, right? And I don't want to disrespect them, but I feel like you should be applying your brain power to solving business problems, as opposed to your build system.
I kind of disagree with that. But I kind of disagree with that. So absolutely, we should be applying our brain power to solving problems, but the way that you do that is by establishing fast feedback, and investing in getting the fast feedback is, I think, nearly always a good investment.
Yeah, well, I mean, I agree. I mean, the whole, well, let's not go into the monorepo, multi-repo debate. So.
Fair enough.
Yeah. So there was a question about using enterprise business capabilities as a starting point to understand bounded context / domains. Anyone have any opinions on that?
I guess it depends what you mean by enterprise business capabilities. Business capabilities, sure. The enterprise thing makes me nervous because that starts to sound like EJB again. But yeah. So my preferred starting point these days is to do event storming. I think the kind of that gives you that high level abstract picture of the flow of information through the system, and you start to see, little clusters that seem to indicate that there might be something interesting going on in this flow of events that indicate bounded context in your system. And I think thinking in those sorts of terms, I think that one of certainly part of my personal strategy for designing these kinds of systems is always, I want the conversation between the services to be understandable by somebody that's not technical. I want it to operate at that level of abstraction. So you're at the level of the business problem. That's the level of exchange of information between the services, and I think that gives you a good tool for this kind of abstraction. So if that's what the questioner means, I think that's a good starting point. Although the enterprise bit makes me nervous.
So my interpretation of the question is that he refers to business. Well, to me, that's part of business architecture, which is a whole other school of thought, right? Where you're modeling your business as a hierarchy of business capabilities, and also as a series of value streams, and each stage of a value stream invokes a business capability that acts upon a business object, right? So it's some other way of looking at a business as opposed to the more domain-driven, design-influenced way of doing things. So any thoughts, Holly, Glenn?
No, I'm just looking because we've got lots of other really great questions as well.
Oh, okay.
Which is really cool.
Well, let's just we could. Oh gosh, there's a lot. I should use the scroll bar. An interesting one is, if services communicate via REST, does that mean that they're not completely decoupled from one another? As opposed to relying heavily, as opposed to using asynchronous communication?
I would say yes. I would say that they're more, by using synchronous communications in any form, they're more coupled.
Well, wait a minute. Even in an asynchronous situation, right, you still need to know what the format of the schema of the message is. Isn't there coupling to that? Whether I read it off of Kafka or I respond to a thing, if I'm looking for a certain attribute and what it means, there's some coupling there. I'm not sure it's possible to completely decouple, right? It's loosely coupled, not completely uncoupled.
I agree with that, certainly, but I think that when you're talking about synchronous calls, you're coupled in a different way. You're coupled temporally, so you're coupled in time, and that's a significant complexity when you're talking about distributed systems in my view. And I've done quite a lot of asynchronous systems now, and it's a much nicer way of working as a distributed computing model. It was one of the things I'm kind of interested in. I don't know whether we're going to get there, but I think that one of the potential future directions for microservices is probably the adoption of the actor approach. So little stateful bubbles, that just take asynchronous messages. And I think that gives you an opportunity to kind of, better than any other approach that I've seen, separate accidental and essential complexity. So I'm a big fan of asynchronous systems for distributed systems these days.
Holly?
Yeah, I've got two thoughts. The one is about, so I'm going to jump all over, because the one is about the coupling, because I think you're spot on that there's kinds of coupling and temporal coupling, and Chris was talking about design coupling in an article recently. But Kent Beck wrote an article which I really liked, and he was talking about the fact that we have this sort of dream of decoupling, but if they're talking together, they are going to be, or even if they're, if they're interacting in any way, they're going to be coupled. So it's about managing the coupling, and managing the coupling is something that it's sort of, I like it because it implies that there's a number of different ways that we may want to manage it. We probably want to reduce it, almost certainly, but we probably want to think about what our objectives are as well. And being really explicit about it is another thing that we want to do. Understanding the costs and the trade-offs is another thing that we want to do. And so there's sort of a spectrum. But I mean, I'm intrigued by the idea of the actors as well, because that feels like one of those ideas that's a really good idea, and it's come around a lot of times, and everybody has gone, that's a very good idea, and once I understand it really well, I'm going to implement it. And then it sort of fades back out, because if you look at something like Akka or Scala, they've always stayed niche, and so I wonder whether it's just too hard for mere mortals, even if it's elegant.
Interestingly, people are pretty comfortable with the term event-driven architecture. Yeah, and then you get into, well, what's the difference between an event-driven service and an actor-style service? And they seem kind of close at some level.
Yeah, I think there's some interesting moves. I think there's some interesting moves. I think Holly's right that it's a bit grungy. You've got to be a bit nerdy to go there at the moment, I think, with the tools and stuff. And there's a lot of the conversations around it. But I think in the future, it's one of the directions that I think that distributed computing will take, because I think it's a simpler model for concurrency. And that's one of these deep problems that you can't avoid. If you got concurrent information going on, that's going to make your system hard. Whatever else is happening, it means it's going to be hard. And actor is a way of simplifying that and allowing us to move more of the smarts out of the actual bit of code that's doing the work. Because the bit of code that's doing the work is kind of single threaded. It's just taking an event in, doing something, maybe even something stateful, and then putting an event out. And that's lovely. That's a lovely way of programming. So I think there are some rooms for it to take on, and I wonder whether that's one of those old ideas that whose time might come with moves into the cloud and serverless, stateful serverless, and all those kinds of things potentially.
Maybe it just needs the right marketing and just something that just captures that mental model, that captures the imagination, like microservices have.
Right,
there's got to be a better programming one. Yeah.
Microactive?
Micro. Isn't that Tom Cruise?
That's good. I'm just going through these questions. It's a really interesting one, which is, what about Conway's law in a company that frequently reorganizes? Which I feel like that's I've sort of encountered versions of that question every so often.
I mean, that's a bigger problem, right? I mean, that's if the company is constantly reorganizing. In other words, if you don't know who your boss is on a month-to-month basis, for example, right? Or if you get moved around a lot to different teams, there's cultural implications to that. Like, you've got bigger problems. You're not even worried about Conway's law anymore. I mean, that's, constant reorganization does not do well in terms of team performance, frankly. I mean, yes, it happens sometimes. It's unavoidable. But if it's just a never-ending churn, you've got bigger cultural problems than how long it's going to take to get some microservice owned by another team to add the feature that you need.
Oh, good. I'm going to
And
disagree.
Conway's,
Oh, good.
Conway's law probably still
Good.
will hold, won't it? It's just because you can sort of look through
Yeah.
the architecture and you can see like the stratifications, and you can do the archaeology, and you can say, well, this here was where it was owned by this team. And then you see this sort of disgusting mess here where it sort of got split into two, but it didn't get refactored properly. That was during the transition phase. And now we have the next layer, and it's like the tree rings of ick.
I think I do disagree slightly. I think really I'll give the consultant's answer, which is it depends, because I think depending on the context. So I worked in an organisation where we morphed a lot. We kind of changed shape dynamically to fit the situation, and that was a good in that organisation in the context of the work that we were doing. That was a good thing. Certainly, where you have kind of the top-down, management consultant-driven, culture reorgs on a regular basis, that's not usually a good thing. But I think that if the team is responding to the dynamic changes in the business and the technology and your understanding of the problem, I don't think that's a bad thing necessarily. And I think that what you need to be able to do that are flexible, loosely, what Conway's law, where Conway's law drives you for that kind of team is flexible, manage coupling between the pieces, so that you can compose them in different ways and use them in different ways and work on them in different ways, I think.
Maybe sort of implicit in that is like one, perhaps that implies that service ownership might change.
Yeah.
And then, or maybe service boundaries might change, right? Which to me, I feel, I guess you got to do what you got to do, but it feels like somewhat expensive. And it's sort of maybe I suppose the other part is maybe if you're in a domain, you're a startup and you're in a domain where you're still trying to figure things out and you're undergoing this evolution, that maybe you should be using a monolith still until things settle down.
Yeah, and that was one of the things that I talked about in the video that you mentioned on my channel, which was that when you're in that fast discovery phase, when you don't know the answers yet, you want to be riffing fast, and you don't want lots of repository boundaries and everything else in the way. You just want to be able to move quickly so you can try different ideas and change things cheaply, and then as the structures and the architecture of the system, your service boundaries and the protocols of exchange between them and so on start to stabilize. That's the time when you start pulling things out, and that they then tend to be more durable. But even then, you might be, you never finished with a service, but one might not be in active development for a while because it's doing its job, and you might move on and you have people working on other things. So I think that the ownership of those things certainly morphs.
Yeah, we seem to have lost Holly.
I noticed in the chat people are still talking about the actor model. So permit me to kind of chime in. What I've found is the issue isn't so much that the actor model is hard or not. The issue is, are engineers paying attention to the threading model that they're currently coding in? And sometimes I've seen that issues with the actor model. Sometimes I've seen issues with a Netty-based system versus a Jetty-based system. In a Jetty-based system, the thread is sort of committed. The thread of the request is committed. In a Netty-based system, that's not true. And so you can run into bugs not caught by the compiler, not easily caught in code reviews, especially if they're not paying that much attention, where you realize that you're blocking more than what you think you're blocking, and you run into some problems there. So I wouldn't say that the actor model is too hard per se. Where I'm at now, ours is a predominantly Scala shop. We use Akka a lot. So it's not hard per se, but you do have to understand how threading happens in your environment in order to avoid some more subtle bugs.
Not within the actor itself, though. So in the infrastructure, yeah.
Yeah, just to understand, you know, it's not like actors are hard. It's just if you're going to do a lot of concurrency across threads, then all of a sudden what thread this code is executing in is important, you know, kind of thing. Are you being called from deep inside of an actor, or are you just being called from the router or the controller, whatever, however you frame that? You know, it's just all of a sudden that becomes important.
I think you've hit on an important point because you know, we're talking about some stuff that is genuinely world-class hard now. You know, when you're talking about concurrent systems of almost any kind, that's our version of quantum mechanics. That's you know, a distributed system is orders of magnitude more difficult than a local system. Because of concurrency, and we buy into that world-class difficulty, immediately we take a branch in a version control system or spawn a thread. You know, as soon as we take that step, we've made our world more complicated. And so understanding that and managing that needs to be part of our jobs. But at the same time, I think that we should be much more scared of it, much more nervous of it than often we are. I've had the pleasure of working with a few people who are considered to be world experts in concurrent systems. One of my good friends, Martin Thompson, is famous for high performance computing and concurrency and all that kind of stuff, and he's brilliant at it. And his advice to everybody is that, you know, don't do concurrency unless you're really forced into it. Don't, because it's expensive, it's slow, it's inefficient in nearly all of the models. So I think, you know, deeply you've got to worry about those things. You've got to worry about coupling, and you've got to worry about concurrency. Everything else is easy. And those are the things that make our job hard, but also interesting, you know. But I think I'd agree with you. You know, it's we need to think about that stuff and how to manage it.
Well, yeah, sort of maybe I view it in a slightly different way, but I feel like there's various models, and the simpler one is like request level parallelism with using a single ACID database. Right. I mean, that's kind of a simple world. And then there's deviations from that. And one of them, like say with the microservice architecture, with each service having its own database, then you're giving up on ACID, right? And you know, that acronym BASE is one, more eventual consistency, and that's quite complex, or has the potential to be very complex.
Yeah, I think one of the big strengths of the relational database model, which I confess I never liked very much, but one of the big strengths of it was that it made the programming simpler because it constrained you. You know, you got the infrastructure looked over some of these problems. The systems weren't very scalable, they weren't very efficient as a result, but it was a simpler programming model. And as soon as you kind of, you know, you do NoSQL or whatever else, you know, the more distributed approaches, you buy into this more complex world, I think.
Yeah. And as Holly just demonstrated, the network is not reliable.
It was like I did it on purpose.
Yeah, you're just making that was your contribution to that part of the panel discussion.
Yep. See, if I was a microservice, that's what you have to factor in. Is, you know, your microservice on the other side might go away.
Yeah, always.
Very true.
Well, fortunately, the circuit breaker had a fallback strategy implemented, so we just carried on talking. Oh my God, has anyone seen any other really great questions that sort of jump out at them?
Oh, there's loads. It's so good. Yeah, everybody's really lots and lots of great questions. Too many for us to answer.
So, this is one, and I'm going to ask David first. So, service mesh, is that a legitimate thing, or is it just an embodiment of an anti-pattern?
I think I'm probably a believer. So the best big system that I ever saw or worked on, we built a financial exchange, and we built it wasn't called we didn't call it a service mesh then. I think it was before that term was became currency. But we absolutely built a service mesh. We built a bunch of stuff that made it really easy to just create a service and to give us loads of accidental complexity stuff like clustering, pub sub messaging, close to guaranteed delivery, failover, all of those kinds of things in the mesh. All we had to do was write a little Java object.
So that may be a subtly different definition. To me, the sort of a service mesh is, say, something like Istio, right? And it's basically managing synchronous communication between services.
Okay. See, I think that contradiction actually is super interesting because, sorry, Dave, because I think a lot of people look at Istio and they say, I don't want Istio. I don't want a service mesh. That's much too complicated. I'm just going to write a few little things to allow me to find my services and allow me to deal with some of the security. And then all of a sudden, you still have a service mesh like the one Dave described. It's just that you've written it yourself and you have to maintain it yourself, which may or may not be what you wanted to do. And we sort of think, oh, this isn't a service mesh, like Chris said, but it is. It's doing stuff.
I mean, for me, what you want is resilience, security, discoverability. Whether you embed that or you make it another server round trip is the question of service mesh. But I don't think anyone's saying no resilience, no discoverability, no security, right? They're just saying, do you want a control plane and a data plane and factor it off to another service? And I would argue that, like for backend service orchestration, it kind of doesn't matter. But if you're starting to do BFFs, backend for front end, right? And you're having front end developers support the BFF because it's so tightly coupled to the front end, they're not used to resilience issues. Yeah. And so if they can just call a service mesh, and in their code, it just looks naive. It just looks like, yeah, I called it. Ooh, I got the answer. Oh, great. Let's put it together, right? Then service mesh has value, right? But if you don't really have that use case, then yeah, maybe it's not worth the complexity, the ops expense, the fact that the sidecar proxy may not spin up in time for your pod to pass the readiness probe in a Kubernetes world. You know, there's all kinds of little details about that you have to deal with in Istio and stuff like that. It kind of just depends on how much orchestration you're doing and what team is doing is owning the orchestration code.
I certainly would react badly to the kind of service mesh that you just described. I think my model of a service mesh, that kind of substrate in the space-time continuum on which our little services rest, is kind of different, and in large part driven by this kind of modeling idea of trying to move the accidental complexity out of my services and allow the service mesh to look after that. The degree to which you've got to architect for that. You've got to understand the principles involved, but actually as an individual service developer, you don't need to, if you get that right. And I think one of the things that frustrates the hell out of me is that we got quite close to what I saw like an ideal development world on this project that I was talking about before. And at the time I was thinking, this is fantastic, we should try and find a way of generalizing this and getting this out for more people to use. And I haven't seen anything do that. I don't know, Akka comes close maybe with some of the things, but still everybody has to worry about too much detail, it seems to. And I think I think there's a future there, and somebody at some point needs to grasp it, because I think there's a way of raising the level of abstraction to allow these services to work more independently, because there's a lot of stuff you can generalize in that service mesh and just kind of provide out of the box sort of. I'm loath to say that, particularly given Holly's earlier comments, but kind of super EJB kind of thing that just does more in the infrastructure. It would be better than EJB.
So on that note,
traumatized everybody by mentioning EJB. We're all just going to go and have a bath now.
At least it wasn't entity beans. So unfortunately, we're out of time. I'm getting texts saying we need to wrap up, but there is a Zoom Hangout, apparently, which we could all participate in for an informal chat, and I hope everyone will join right after this. So yeah, well, thanks. This was fun. It was interesting, and thanks to everyone who's listening. Thank you.